The James Webb Telescope is shaking our laid-out presumptions. Webb has already identified an entire series of galaxies that are too large and massive for their early development. This raises a pivotal issue. If we had previously broadcasted our models of early universe development, might we have misjudged the beginning of the universe too? Although the Big Bang theory has long been accepted, it is currently undergoing increasing analysis. So, it's possible that the Big Bang was not the start of everything after all, that it was in no way, shape, or form the grandiose beginning signal, but just one of an endless number of changes. In this context, the next fascinating question is, did something exist before the Big Bang? Our entire universe was in a hot, thick state then, almost 14 billion years ago. Expansion began. Not just fans of the cult geek sitcom The Theory of Big Bang know how the birth of the universe occurred. According to our current understanding, the often referred to Big Bang describes the event in which space, time, and matter rose out of a singularity around 13.8 billion years ago, preparing for all that used to be, is today, and will be in the future. So far, so liberally accepted. But how could we possibly know today what happened 13.8 billion years ago? Well, it's quite simple. By checking an improvement that started with the Big Bang and continues right up to the present day. As is notable, the universe is in no way, shape, or form an unbending, perpetual substance, but a developing entity that has been growing continuously since the moment of its creation. For a better understanding, it should be mentioned that the universe isn't venturing into current space. No, it is rather space itself that is constantly expanding. And if we now trace back the development of the universe in time with the help of Einstein's general theory of relativity, we ultimately arrive where the density of matter and energy is infinite, where spatial distances are zero. So, we've counted back to the hot, thick state from the theory of the universe's origin. However, the theoretical estimations are not the only thing that has helped the Big Bang theory to its current prominent position. There is also the cosmic background radiation. This is radiation in the microwave range that was created about 380,000 years after the introduction of the universe, which still fills the entire universe today. Since this radiation was theoretically predicted in the Standard Model, its real identification is considered fundamental proof for the Big Bang theory. Yet, despite all the numerical models and found radiation relics, we should not disregard that the Big Bang also raises more questions than it answers in other regards. According to our understanding, the early universe should have encountered the first major expansion spray in parts of a second, extending by a factor of 10 to the power of 30 to 10 to the power of 100 in this absurdly short time frame. However, how exactly this so-called big expansion happened, and whether it truly happened, is just as hazy as the following question. Was there something before the Big Bang? In fact, the theory of the Big Bang alone can't solve all infinite mysteries. For instance, there is the question of what really occurred at the foundation of the grandiose birth. In other words, what caused something to suddenly arise from nothing 13.8 billion years ago? Was there a trigger for it, or was it pure happenstance? And how could matter emerge from nothing at all? Well, Stephen Hawking approached this complex theme in a manner that was both straightforward and consistent. The genius, who passed on in 2018, was quoted as saying, "The question of what was before the Big Bang is just as futile as asking which is north of the North Pole, since time itself only began with the Big Bang. This is an event that can't have been caused by anyone or anything. The laws of nature themselves tell us that the universe could have appeared without the need for energy or a reason." However, other specialists disapprove of this assumption. But more on that in a moment. No less questionable is the topic of why matter and radiation are so evenly distributed in the universe. Regardless of which direction or distance we look on a huge scale, galaxies, gas nebulae, and radiation all show similar densities and distributions. The current explanations highlight cosmic inflation, but some specialists propose that this process continues to this day, and that a huge number of parallel universes have formed in the process. The Big Bang theory, as a little break, can be said to be, despite its overall acceptance, anything but uncontroversial. We are still far from fully understanding its origin. Over time, several other options have emerged that attempt to make sense of the question of the vast start in a totally different way. And even though the corresponding theories sometimes radically differ from each other, they all share a crucial common characteristic. We must abandon the idea that the Big Bang was the beginning of everything. If there was another universe before the Big Bang was simply the sensitive transition from one universe to another. It would, therefore, be better described as the Big Bounce. But what exactly does that mean? Are there any substantial hints that support the existence of such a repetitive universe? Well, on a basic level, the idea of the interaction between annihilation and resurrection is anything but new. The early Indian Vedas, for instance, describe the universe as a cycle of creation, destruction, and recreation that repeats itself endlessly. The Maya had a very similar perspective. Einstein himself spent some time considering the possibility of a cyclic, repetitive universe and thought it was very plausible. According to the saying, what expands can also contract again. Cyclic models are still being considered. Very famous in cosmology today, this is scarcely astonishing, since this approach is ready to bypass the issue of cause. Assuming that matter has consistently existed in an everlasting cycle, the subject of how something can emerge from nothing is likewise now not pertinent. In such a setting, there has essentially never been such a thing as a flat, don't doubt anything. And in this case, the abnormal consistency of the universe could also be made sense of by a huge contraction, which appropriates basically everything similarly. The trigger for the Big Bang would be just as simple to find. It was basically the finish of the past cycle, which was trailed by another period of expansion. So, everything could be so simple if not for the issue of entropy. As indicated by the second law of thermodynamics, the degree of confusion in a closed system generally increases, and this also applies to the universe. Because of the always new cycles, entropy would consequently need to increase perpetually. This actually means that with each infinite fresh start, somewhat more radiation is made corresponding to matter, and that the universe will ultimately arrive at a state of maximum entropy, in which neither particles, nor stars, nor galaxies can exist. But that's not all. Because of the entropy issue, more and more disordered particles would be crushed along with every contraction of the universe, while the following new beginning would be accompanied by a stronger dispersal. Alternatively, this means nothing other than that each new cycle would constantly endure somewhat longer than the previous one. According to the past, anyway, this would also imply that the cycles are getting increasingly short the further back we look. And similarly, with the theory of how things came to be, we would also arrive at a beginning point where everything is concentrated, the neglect of the universe. So, might we at any point now file the cyclic models away? After all, the corresponding speculations unequivocally bar a primitive start of everything. Well, we shouldn't excuse the possibility of a timeless cycle so rapidly. In fact, researchers have now figured out how to settle the entropy issue, and everything necessary is a universe experiencing a serious form of cognitive decline. To grasp what this implies, we need to take a brief diversion into the world of loop quantum gravity. As per this theory, and in spite of Einstein's suspicions, the texture of spacetime isn't continuous, but is rather separated into minuscule, inseparable units. The autonomous loops have a degree of 10 to the power of minus 35 meters, which compares to the Planck length and accordingly the smallest possible unit of quantum theory. All in all, the interconnected loops form the essential structure of the universe, with the particles representing the nodes of the net-like structure. In such a way, we can envision the universe as a solitary floating of continually changing minuscule associations that are neither apparent nor substantial to us. In this context, the first peculiarity of the universe can't have existed. Loop quantum gravity only permits for limited physical qualities, which means that an infinite density isn't passable at the same moment. Anyway, the quantization then causes an event that is no less marvelous. At the point of the Big Bang, gravity is switched. Rather than applying an attractive force as expected, it suddenly pushes everything away. Consequently, space is essentially turned backward, which in turn has some surprising outcomes. As a result, the loop model in a real sense shouts that the Big Bang was not the start of everything. As opposed to the theory of relativity, it also yields substantial numerical outcomes before the Big Bang, So there could truly be a major skip in which a predecessor universe falls in on itself and is then driven back into larger scopes by the countergravitational impact of its own infinitesimal organization. Conveniently, the subsequent fluctuations in matter and energy density would eradicate all information from the past universe. In general, every new universe experiences an extreme case of memory loss, which thus also provides a solution to the problem of entropy. Since it is practically reset to zero, the universe can remove its old entropy binds and start over again. Lighthearted also, now go ahead and start raising a ruckus around the town, like and subscribe buttons become a part of our community, and never miss a new video from us again. We'll see you soon.